We will explore the 5 basic probability rules. The first rule says that the probability of any event is a number between 0 and 1, including 0 and 1. The second rule states that the probability of the sample space is 1. The third rule says that the probability of A complement is 1 minus the probability of A. And the fourth rule says that the probability of A or B equals to the probability of A plus the probability of B minus the probability of A and B. And the last rule states that the probability of A and B equals to the probability of A times the probability of B given A, or the probability of B times the probability of A given B. The first rule states that the probability is a number between 0 and 1. If the probability of an event A is 0, then it is impossible for the event to occur. If the probability is 1, then it is certain that the event occurs. The probability cannot be a negative number, nor can it be a number that is more than 1. It can be 0 and 1, and any number between 0 and 1. The second rule states that the probability of the sample space consists of all of the possible outcomes is precisely 1. This is because the sample space consists of all of the possible outcomes, and some outcome must occur on every trial. The sum of all of the possibilities of all of the possible outcomes must be exactly 1. The third rule states that the probability of A complement is 1 minus the probability of A. If A is an event inside the sample space, then A complement is anything that is not in A. So A and A complement made up of the sample space, whether you are in A or you are not in A. If you're not in A, then you are in A complement. Because the probability of the sample space is 1, the probability of A is 1 minus the probability of A complements, and vice versa. The probability of A complement is 1 minus the probability of A. We defined A or B as something that occurs in the event A, or something that occurs in the event B, or both. That is, the probability of A or B is the chance that something happens in A, or something happens in B, or in both. Because of this, to find the probability of A or B, this is known as the general addition rule. We take the probability of A, the first event, and we add to the probability of the second event, the second piece. Notice that when we take the first piece and add to the second piece, we counted the intersection twice. The intersection is what the two have in common. This is known as A and B. Thus, the probability of A or B is the probability of A plus the probability of B minus the probability of A and B. Because we double counted this piece, the intersection, we have to take one away. The last rule is known as the product rule or multiplication rule. The probability of A and B is the product of the probability of A and the probability of B. But since we don't know whether the two events are independent or not, we have to update the second probability. The notation for the second probability is known as the conditional probability. We read this as the probability of B given A, meaning the probability of the second event given that the first event occurred. And P of A vertical bar is read as the probability of A given B, that is, the probability of event A given that the event B occur. Rule number 4. The addition rule can be simplified if the event A and B are mutually exclusive, meaning that the two events have nothing in common. Notice that if A and B are mutually exclusive, then the probability of A and B is 0, since the intersection is empty. They don't connect. So if the two events are mutually exclusive or disjoint, then the probability of A or B is simply P of A plus P of B. Notice that we still keep in mind that we will need to subtract P of A and B, but if the two are disjoint, then the third term is 0. Only use this formula if we know for sure that the two events are mutually exclusive or disjoint. If the two events are independent, meaning one event does not influence the probability of the other. If A and B are two independent events, then the probability of A and B is simply the probability of A times the probability of B. This time, we do not need to use the probability of B given A for the second factor, because if the two events are independent, then they don't influence each other. One probability doesn't depend on the other. The probability of A does not influence or affect the probability of B. If A and B are independent, then the probability of B given A is simply the probability of B. That is, if the two events are independent, then it has a forgetful properties. That is, it has no memory of what happened to the previous event.